Alright everyone, so in this video we're going to see how we use the t-distribution. In particular, how do we utilize the t-table to help us construct confidence intervals in the near future. But first off, we're going to have to establish some notation. Now, we've seen this notation in the past, but applied to a different distribution. There's t, and in the subscript is some indication for degrees of freedom, and then usually there is a small percentage or proportion in the subscript as well. And so what this gets you is a t value. So this is the t value from the t distribution with n-1 degrees of freedom, n-1 degrees of freedom, such that there is an area of alpha is in the upper right tail. So we can draw a picture to help us see what this looks like. I'm going to draw a bell-shaped or normal curve, because t-distribution is normally distributed. So I would label this not just t, but I might indicate a particular degrees of freedom there. I always like to put 0 in the middle as a reminder. So if we have an area of alpha, so that's in the upper right tail, so that region, let's call it alpha. Then this notation written above is referring to the tick mark, the t value right here, that green tick mark, that specifies or distinguishes this region such that that area alpha is in the upper right tail. So let's take a look at a couple examples and how we find what that tick mark value is. So I'm going to scroll down here. I've got some problems already set up for us. So let's find the following t values. In this first problem, this says this is the t distribution with 5 degrees of freedom. All right, I'm going to put a tick mark 0 in the middle for the fun of it. 5 degrees of freedom, and the area in the upper right tail is 0.05. 0.05. So we've drawn this scenario here that this is describing. What we want to find is the tick mark right there, that blue tick mark that makes or distinguishes this region. So we have a t-table. It is posted on Canvas, and I'm going to pull it up right now, show you what it looks like. Okay, so a lot of numbers on this t-table. Here's how it's organized. On the left, very first column, it says degrees of freedom. Remember, that's just n-1. And so when you're looking at one of these rows, you're really just focusing on one row at a time. You go to the degrees of freedom that is relevant for the situation and just focus on that row. In this example, since we are focusing on 5 degrees of freedom, I'm really only going to look at that row that I've highlighted. So these are the tick mark values that define this upper tailed region in the right tail. Notice each column, this says 0.2, 0.1, 0.05, 0.04, getting smaller and smaller and smaller. Since those are getting smaller and smaller regions, areas in the upper tail, now look at the numbers that I've highlighted. These are all getting bigger. And they're very different values. These are tick marks, t-values. But these decimals on top, those are areas. So to address this question, we just need to go to the degrees of freedom of 5 and where the column says 0.05. We just need to see where those meet up. So our solution here is 2.015. 2.015 is our answer. I can say equals. Great. For this next question, it looks like it still is considering an area of 0.05 in the upper right tail, except now this is for the t distribution with 25 degrees of freedom. So I'll label this T25. I like my 0 in the middle. And we want to find the tick mark right there. I'm going to go back to the t table. We're going to go to the row that says 25 and the column that says 0.05. I'm going to scroll down and see where this column and this row intersect. It appears that our solution here will be 1.708. In this third question here, it looks like we're going back to 5 degrees of freedom, but this time the area in the upper tail is 0.025. So let's compare this third question to this first question. Okay, let's look up at the top image here, because that still is the curve with 5 degrees of freedom. And I'm highlighting a smaller area here in purple. I'm trying to illustrate 0.025. And we want to find this time the tick mark associated with that area in the upper right tail. And hopefully you can kind of see that because it's a smaller area, it's actually going to have a tick mark that is further to the right on this axis, yeah? So just something to anticipate is our answer when we go to the t-table is going to be a little bit larger than 2.015. Let's take a look at the t-table. We want to go to 5 degrees of freedom with 0.025. Okay, 5 degrees of freedom and 0.025 is right here. Okay, so that is our tick mark solution, 2.571. Hopefully that makes sense, that that's going to be a bigger number than our answer from part A there. Scrolling down again, let's look at 46 degrees of freedom, and we want to find the degrees of, we want to find the t-value such that the area to its right is 0.025. So let's go back to the t-table. Okay, 46 degrees of freedom, you'll see, is not listed here. There's a 40 and there's a 50. So if this happens, I think an easy way to address this is just to use the closest degrees of freedom. 46 is what was given, so we'll go to 50. And we want to go to the column that says 0.025. I'm going to scroll back up. Looks like it's this one that my cursor is on. And I have highlighted the intersection of that row and that column, 2.009. Okay, in this last little setup here, we're actually going to calculate two things. And we have to do just an itsy bit of math in order to achieve that. So we're kind of told this in an indirect way. This is saying to find the t-value from 10 degrees of freedom with 0.01 in the right tail, and this other t-value, still from 10 degrees of freedom, but look, it says take alpha and chop it in half. So that's 0.005. So we need to go to t-table, 10 degrees of freedom, and look up 0.01 and 0.005. Okay, so 10 degrees of freedom and 0.01 is all the way over here, and 0.005 is right next door. So those are our two answers, 2.764, 3.169. That concludes using a quick demo on how to use the t-table. I did want to mention that we used the closest degrees of freedom when it's not written on the table. In the next video, we're going to put all of this together so that way we can see a formula for a confidence interval for a population mean, and that's going to incorporate using the t-table.